Today, we will take a look into a geometric sum. Now, the main idea here is that when we are working with the geometric sequence, which we're going to talk about in a second, if we have a geometric sequence and we want to add the term up to a certain point, then we can call that a geometric sum. A geometric sum can be given to you in the following formula, but the following formula, we use the following formula when it comes to finance math, which finance math is just mathematics in finance. We can use mathematics in many branches. One of those branches is economics or finance. We can use a geometric sum in finance math. Now, this is just a formula, but notice that anytime you want to use a formula, you need to just know what each variable stands for. Where A1 is going to be the first term, R is going to be the common ratio, and N is going to be the number of terms in that sequence. We will use this formula in a second, but before we use this formula, we need to figure out, well, what is a geometric sequence? Well, here's a small introduction. A geometric sequence is any sequence that has a pattern of either multiplication or division, which is important here. When we call a pattern, we call that a common ratio here when it comes to a geometric sequence. Right now we have two sequences, arithmetic and geometric. For arithmetic, it's if the pattern is addition or subtraction. For geometric, that is if the pattern is multiplication or division. And this is a typo, should have said or division. And we're going to call that a common ratio. So let's start with the following. Can we classify the following as a geometric sequence? Let's observe. Can we figure out a pattern? Well, notice that for me to go from 1 to 2, I could have multiplied this by 2. To go to 2 to 4, I could have multiplied this by 2 as well. So notice that here we can see a pattern here. And this pattern is of multiplication of 2, because if you want to reach the next number, all you got to do is just get the previous one and multiply it by 2. Because the pattern is of multiplication, then yes, this is geometric. This is an example of a geometric sequence. So let's look at the next example here. For example B, we got to see, well, is this geometric or not? All you got to do is, does it have a common ratio? Well, let's check. 4, I can see that 4, if I multiply by, I can see that 3, if I multiply by 4, I can get 12. And 12, if I multiply by 4, I can get 48. And 48, if I multiply by 4, can I get 192? Well, let's just check that, just to be sure. So we got 48. If we multiply this by 4, we're going to get 192. Perfect. So yes, notice that here we have a pattern of a geometric sequence because we do multiply by 4 to reach the next number. So this is an example of a geometric sequence. Now, before we move on, let's actually write down our answer completely, because here it's important for you to identify that the common difference or the common ratio in the first example was 2, because that's what we were multiplying by. In example B, the common ratio is 4, because now notice what's going to happen in example C. If we look at example C, we can see that how are we reaching the next number? That's the question here. Well, the first pattern that I see is that you are dividing by 2, because 100 divided by 2, you get 50. 50, you divide it by 2, you get 25. And 25, if you divide it by 2, you get 12.5. Okay, perfect. But the common ratio, it's always in terms of multiplication. But we see that we're dividing by 2. So this means that the common ratio is the common ratio equals to 2. No, because you are dividing by 2. The common ratio should always be in terms of multiplication. So instead of saying that we're dividing by 2, to divide by 2, that's the same as to multiply by 1/2. And let's check it. We have a calculator here. Let's just check it. 100 times 1/2. We get, oh, I'm sorry, that's 1,000. So 100 times 1/2. Yes, that's 50. If we multiply by 1/2 again, we get 25. So notice that to divide by 2, that's the same as to multiply by 1/2. So yes, this is an example of a geometric sequence. Where the common ratio is 1/2. So these are just small examples as to what a geometric sequence is. But we have not talked about the main idea here, and that is the idea of a geometric series. I'm sorry, a geometric sum, which we can talk about it as a geometric series as well. So notice the direction here. It says, find the sum of the finite geometric series. Now, we want to do this both ways. We want to do this by adding the numbers, and we want to use the formula to verify that that is true. So again, what a geometric series is, it's pretty much telling you, look at the first 20 terms and add them up. Tell me what the number is. And then we can call that a geometric sum up to the 20th term. We can go to the 5th term, we can go to the 7th term. It doesn't matter. You're just going to be adding those terms up to a certain point. So we want to find out the geometric series for this sequence here. We're going to do it both ways. First, let's do it just by adding the numbers. So if you want to know the series of this sequence, you can see that this is a geometric series or sequence because to reach the next number, you multiply by 2. So let's find out the value for the sum. So the sum is going to be 1 plus 2 plus 4 plus 8 plus 16. Let's see what the value is. 1 plus 2 plus 4 plus 8 plus 16. So that means that the sum of the 5th term is going to have a value of 31. Now, what if we want to find the sum using the formula? Well, let's do it. What do we need to know to use the formula? We need to know these 3 values, which is the first term, which is equal to 1. We need to know the common ratio, which is the pattern, which you can see that in order for you to reach the next number, you're multiplying by 2. So that means that the common ratio is 2. And we need to know how many terms are we adding. So that's 1, 2, 3, 4, 5 terms here. We have these 3 values. We have a sum. Let's actually find out. So S of n is equal to A1, which is 1, minus A1 multiply times R, which is 2, to the n. I don't know why I wrote n here, because we do know the value for n, which is 5. So we have 2 to the 5. And now we have 1 minus r, where r is 2. We can figure out what this number is. Let's figure that out. So we're going to have 1 minus parenthesis 1, parenthesis 2 to the fifth. Let me figure out what the numerator is, which is negative 31. And I need to divide that by 1 minus 2, which is just negative 1. So that gives me 31. But notice that if you use the formula, or if you use just by adding numbers, you're going to obtain the same term. Now, you might say, well, why am I even using the formula? I mean, I can just add the numbers, and that was faster. But notice that this is a simple example. There's times where you might have a sequence with 30 terms, or even 50 or 70 terms. And they're going to ask you to add the first 70 terms. You don't want to just add one by one. You have a formula. All you got to do is find out what the first term is, what the ratio is, how many terms you want to add, plug into the formula, and let the calculator do the work for you. Let's see another example. Let's take a look at example B now. And again, let's do it both ways. Let's add it up. First, let's find out the sum. Let's find out the sum. Sorry for the pen. Let's find out the sum. So we're going to get 3. We're going to add it by 12. We're going to add 48. And we're going to add 192. Let's do it by adding. So 3 plus 12 plus 48 plus 192. All right, perfect. So that means that S of n has a value of 255. Perfect. Let's use the formula now. And let me just bring the formula for you. Let me just bring the formula down. And the variables. Let's just have it here as a reference. So we have the formula, and here we know what each variable stands for. Perfect. So let's figure out what those are. What is the first term in this sequence? Well, this is 3. What is the common ratio of the sequence? So notice that in order for you to reach the next number, you needed to multiply by 4. So that means that the common ratio is 4. Now n stands for how many terms are we adding? Well, that's 4, because that's 1, 2, 3, 4. We're adding 4 terms. We have the values, we have a formula. Let's plug that in. So S of n is equal to A1, which is 3, minus A1, which is 3, times r, which is 4, which has an exponent of 4, everything divided by 1 minus r, where r is equal to 4. Perfect. Let's figure out what that is. So let me figure out the numerator first. So now we're going to have 3 minus parenthesis 3, parenthesis 4, exponent 4. So we know that the numerator is going to be negative 765 divided by 1 minus 4, which is negative 3. So we're going to get negative 765 divided by negative 3. And there you have it. This will give you the same result. The only difference is that it's faster when you deal with a lot of terms here, which we're not going to do here in this video. So now, here's your entrance ticket. Find the sum of the finite geometric series. And do it both ways. Do it by adding the numbers, and do it by verifying it using the geometric series formula.